one, we've been looking at solution concentrations, we're looking at types of solutions on the solubility curves, looking at whether they're saturated, unsaturated, or supersaturated. So what type of solution do you think most of them are? So think of the solutions you encounter in your refrigerator or your bathroom. Are they saturated, unsaturated, or supersaturated? So I'm going to give you a moment to think about that. If you think of, most of them aren't like the sugar solution. They don't settle out over time. They don't have solid chunks in them. So most of them are going to be unsaturated solutions. Okay? Saturated solutions tend to be very concentrated solutions. So there's different types of solutions. So for these saturated solutions, the ratio of solute to solvent is high, or there's lots of solute. So that's what's called a concentrated. The ones that don't have a lot of solute, so their ratio of solute to solvent is very low and there's very little solute, you want to make sure that you understand that those are what we call dilute solutions. So we're going to need a way to describe the variations in concentration. So saying they're dilute versus concentration isn't going to tell you how much solute gets dissolved and how much solvent or solution. So maybe some of you wear contact lenses. When you buy contact solution, it's going to be the same concentration of salt every time you buy it. So saline is just another way of saying a salt solution. So there has to be a numerical value with it. We're going to proceed down the sheet to explain that. And there is an equation for that. This is called mass percent. So you want to fill in mass percent on your worksheet. And it's equal to the mass of the solute. I remember solute is what's being dissolved divided by the mass of the solution. Okay. And remember, solution has two parts. It's the solute plus the solvent. So you need both parts to get a solution. So we have this top equation where it says mass of solute over mass of solution times 100. Again, that's the definition of percent. But we can also write it as the mass of the solute over the mass of the solute plus the mass of the solvent. So it's a little bit longer this way, but again, it's the same thing. It's just showing the two parts of the solution. So that's another way to express your mass percent. The first example I have up here is what is the solution concentration of 40.0 grams of salt dissolved to make 100.0 grams of solution. You may see some slight differences on your worksheet. I did make some edits to this after I printed it, so please make sure that you make those edits. So when you're reading this problem, you really need to start thinking of salt means solute, so I'm identifying that. Water is my solvent, and then the water plus the solute is the solution. So for this one, since I have the solution already, this is going to be set up as 40.0 grams divided by 100 grams of solution. So I don't have to add in this one because this is already a solution, and then I'm just going to multiply that times 100. Okay. So this one's pretty easy. Your hundreds cancel, and you get 40.0%. So 40.0%. If we look at this problem and we change it just slightly, so this next problem is going to sound the very same, but it's different. What is the solution concentration of 40 grams of salt and 100 grams of water? So we're changing the word solution in the first problem to the word water in the second problem. So this now means we have to add, like you see up here, because the whole solution is the water plus the salt. So we'll have 40.0 grams on the top. And on the bottom, we're going to have 40.0 grams plus 100 grams, because those two things together are what make a solution. So individually, neither one of them is the solution, but combined, they make the solution times 100. Now, this one you're probably going to want to put into a calculator. So again, if you need to get a calculator, pause the screen and get one of those. When you enter this into your calculator, you need to be really careful that you do it correctly. So if you remember your order of operations, if you do 40 divided by 40 plus 100, it's not going to do it correctly. So the 40 plus 100 has to be in parentheses, or you can kind of do it as a two-step problem and put 40.0 grams over 140 grams and then divide it in your calculator. So either way, it will give you the right answer. Again, this one's easy. You could do 140 in your head. You wouldn't actually have to show the work for that one. But some of them it's a little more challenging to come up with that. So when you multiply that together, you're going to get 28.6%. And again, I'm using 3 sig figs here. We haven't talked about those for a while because each of my numbers have at least 3 sig figs. So 40 has 3 sig figs, and 100 has 4 sig figs. So when I multiply, I take the least amount. So either way you calculate this, you get 28.6%. So the next thing you're going to see on the worksheet is that just in solubility curve problems, it's important to look for those keywords, water or solution. So make sure you're looking for those as you go through the problems. The difference how you put them in. If you flip to page 2, you see example number 3. So we have 43.0 grams of KClO3, that's called potassium chlorate, are dissolved in 100 grams of water. So again, my thought process needs to be, what are we doing here? So KClO3, that's the name of the salt. So that's going to be my solute, okay? And it's important that I have water, so because I have water, that tells me I'm going to need to add in my problem. So again, I can do it as 43.0 grams over the quantity, 43.0 grams plus 100.0 grams. Again, a lot of these are coming off your solubility curve sheet, so that's why you're seeing the 100. I multiply by 100 to make it a percent. Okay. Or you can do that directly, do 43.0 grams over 143.0 grams and multiply that by 100. And either one of these are going to give you an answer of 30.1%. Again, looking at sig figs, 43 grams is 3 sig figs, 100.0 grams is 4 sig figs, so we're going to keep 3 sig figs in our answer. Again, if you need to write these notes and I'm going too fast for you to be able to write them down, remember you can always pause and go back in the screencast. Example we have here is 87 grams of sugar are dissolved in 200 grams of solution. So again, my first thought process has to be identifying what I have here. So sugar is my solute, and I have solution, so I don't have to add. So I'm not going to have that 2 steps here, so this one will just be 87 grams divided by 200 grams of solution times 100. When I calculate that out, I get 44%. Okay. And again, 2 sig figs here, because 87 is only 2 sig figs, even though the 200.0 is 4 sig figs. Okay. All right, I'm going to ask you to stop at this point. you are going to be working on just the first side of the worksheet on practice solubility curve problems.